Alright guys, welcome to this page of the notes, and again, what we're doing is we're practicing writing similarity transformations, which means that it could be a dilation, which is what we've been working on here most recently for the last couple of sets of notes, but it could also mean going all the way back to chapter 1, that it could be a reflection, a rotation, or a translation, right? Similarity transformations maintain shape, and all of our transformations will maintain the shape. So what we're going to look at here in this next one is writing a similarity transformation that is not just a dilation, but also involves one of those other ones that we talked about back in chapter 1. Anyway, here we go. I'd like you to write the similarity transformation. So first I need to figure out, clearly they're the same shape. They're both rectangles. But I need to find that dilation factor, right? Dilation factor. I need to find that scale factor K, because clearly the red rectangle is bigger than the blue one. So let's find that scale factor and then work on writing our similarity transformation. Now remember, we're going to write the ratios of corresponding sides. So up first, side GK, or KG if you prefer, it doesn't really matter. KG divided by, what is the corresponding side? Well, KG corresponds with OL. Okay, the next one, let's do, KJ. Well, KJ corresponds with ON. Okay, the next one, JH. Well, JH corresponds with, let's see, JH, so that would be NM. And then the last one, I have HG or GH, whichever. That's going to correspond, of course, with my last one, ML. All right, here we go. Let's go through and let's get the links to these sides. Again, this is pretty easy. You could use the distance formula. In fact, if the lines were on an angle, you would have to use the distance formula, but we don't want to make things too terribly difficult, so let's just count, because all my lines are either vertical or horizontal, so we can just count. Let's see here, I got 1, 2, 3, 4, 5, 6, 7, 8, divided by 1, 2, 3, ooh, that's easy. So 8 divided by 4 is going to be 2. Let's hope the rest of them come out to be that. The next one, 1, 2, 3, 4, 5. Okay, so I got 6 divided by 3. So far, so good. Let's keep going. That one, oh, it's a rectangle. I know it has to be the same. So it's going to be 8 over 4, which is 2. And it's going to be, since it's a rectangle, 6 over 3, which is 2. So just like that, awesomeness. These are all the same, which is what I need. That means that my scale factor, K, is equal to 2. Beautiful. But not quite. Check this out. If I do my similarity transformation, which is going to be x, comma y, goes to 2x, comma 2y. Does this similarity transformation get me from here to the red rectangle? Well, let's find out. Let's find out. In green, I have given you the ordered pairs, 2, 1, right? The first one is 2, 1. So we're going to multiply each of those by 2, right? 1 times 2 is 2. 2 times 2 is 4. So I'll be at 2, 4. Let's see, 2 gets me right there. The next one is at 1, 6. Multiply each of those by 2. Well, 1 times 2 is 2. And 2 times 6 would be 12. So my next one would be at 212. Oh, look at that. Sure enough, there it is. 212 so far. We're doing good. Keep checking. 4, 2. 4 times 2 would be 8. 2 times 2 would be 4. So it would be 8. Oh, yep, sure enough. There it is. 8, 4. Fantastic. And my last one, 4, 6. Let's see, 2 times 4 would be 8. 6 times 4 I'm sorry, 6 times 4, geez. 6 times 2 would be 12, and so we'd be at 8, 12, and sure enough, there it is, right? So if I connect all those with a line, and I get exactly the red, or the same red rectangle that was originally in there. So, my similarity transformation, it is in fact a dilation. Awesome, great, so there's another great way where just me giving you two figures, can you figure out, is it a dilation? And sure enough, this one is. Also, just a quick note here, this is a lot of fun. Remember how we find the center of dilation? You can find the center of dilation by drawing a line that connects the corresponding vertices. So K